Hi there. All right, so today we're covering two lessons in this video. So let's jump in and get going. We're going to talk about all things quadratic. Hopefully that'll mostly be review for you. And then we're going to talk about some inequality stuff that might be new. Let's see. First of all, so we're going to start with quadratics here. And so the graph of a quadratic is a parabola. And the equation that we use, we actually have two different quadratic equations that we can use. One's standard form, sometimes it's called vertex form, because the vertex is just sitting there for you in the graph or in the equation. So it would look like this: y equals a, and then in parentheses you'd have x minus h squared, and outside the parentheses is a plus k. When it's in this form, the vertex is really just how much you are shifting right or left. And so in this case, you can see from our transformations that we already know that it's going to go right h up k. That is where it shifts off of the origin. So that is going to be where your vertex is at h k. Notice that inside the parentheses, you always do the opposite. So even though it says a minus h, my vertex would be a positive h. If it said plus h, that x value would be a negative. Okay, general form is more like something that we would be factoring or something like that, and it looks like this. There's not parentheses in it. It's kind of cleaned up. Ax squared plus bx plus c. When it is in this form, you can still find the vertex. There's a formula to find that. It actually comes from completing the square. But the vertex that we have, and really what we have is just a way to find the x value of the vertex. So it is negative b over 2 times a. And of course, we're looking at these two values in your equation. Once you have that, then you're just going to plug that number back in. So so whatever this is, you're going to plug it in up there, and what you get back is going to be your y value. All right, let's give it a shot. Okay, I lied. We're not going to jump in and try one yet. Let's talk about one more thing here. Let's talk about the intercepts on this graph. Now, intercepts on a quadratic aren't really any different than finding intercepts on any graph. We can do them both algebraically and graphically. Let's start off and talk algebraically. Given an equation, which I have just an example up here so I can reference it. Given this equation, to find the x-intercepts, you always plug 0 in for y. And that would be the case with any kind of a function. Oops. If you were to plug 0 in for y, that means you'd put a 0 right here. And then you'd have 0 equals this quadratic. So hopefully when you see that, you think, oh yeah, then we typically would go factor that. That is exactly what you would want to do. Go factor it. That'll get you your two x-intercepts that you have. All right, so hopefully it'll work out nice, but we all know that not everything factors. If it does not factor, you might get to do the quadratic formula to find the x-intercepts. That just means that they don't cross at a nice integer on your x-axis. Now, you plug 0 in for y to get your x-intercept, and you just switch it around. You plug 0 in for x to get your y-intercept. Thinking about up here, if I'm going to plug 0 in here, plug 0 in here, and ultimately just evaluate it, well, those are going to go away. My y-intercept would end up being that negative 40. And that actually is always the case on a quadratic, because these are going to disappear on you, and this number over here ends up being your y-intercept. All right, let's talk graphically. Let's say you're looking at a parabola on your calculator, and maybe nothing comes out real clean on it. So to find your x-intercepts on that, we do have a feature on our calculator that actually finds those. If you go to second trace, you have that whole menu of options, and the zeros that's the mathematical term for your x-intercepts. So you're going to go look for the zeros, and that's how you're going to do the x-intercept. The y-intercept, you're still doing the same thing. You're plugging 0 in for x, but how do you do that graphically? Well, also second trace. you're going to go to value. Value lets you plug anything you want in for x. And so we're going to plug 0 in for x. And it will shoot you back the y-intercept. Now we're going to try one of these. All right, so I really, what I want to try here is trying to write the equation of a parabola, knowing now the formula for that. Could you, and I give you some information like the vertex, could you turn that into an equation of a parabola? So what I know is the vertex. That's going to be handy because that x, I'm going to use the standard form to do this. So the 1 is going to be the, well, it's not, sorry, let me undo that. It's not the x, it's the h and the k on your vertex. But then it passes through this point over here. Passing through a point is ultimately telling you sort of how wide it is or how skinny this parabola is. So this is going to tell us what the a value is. So I'm going to start off, I'm going to write the equation. Don't forget that squared right there. People do it all the time. Don't forget that. So what I'm going to do is I'm going to take the 1, 2, I'm going to put it in for h and k. Now I'm really searching for the a. So what I can do is I can plug this ordered pair that the graph is supposed to go through in for my x and y. Because remember, an equation really is just a set of points that go through the graph. So I'm going to put in for y then a -6. I'm looking for a. I'm going to put a 3 in for the x. And now I'm ready to do my hk. So it's a -1. Don't forget your squared. And then a +2. First thing you want to do is get that 2 over on the other side. And then I'm also going to take this 3 minus 2. And let's go ahead and simplify that. 3 minus 2, I'm sorry, 3 minus 1 is 2. Squared is 4. So this ends up being an a times 4. Divide both sides by 4, and you end up with a -2 for an a value. And then we would come back and actually write our equation. We'd write y equals -2. Now I do know the vertex, so I'm going to keep the vertex in there. So it's going to be x -1 squared plus 2. All right, here's an application of using a quadratic equation. It's called vertical free fall motion, and it represents the height of an object in free fall. So a couple ways that we can work with this, and this particular example is going to be the kind of the scenario where you throw something up or hit a ball up or whatever it is, and then it comes back down. And the formula for this, I would give you this formula, but you would have to know what everything means in it. So S actually stands for position. So this is the position of the ball with respect to time. -1/2 g. G is really just the acceleration due to gravity, which on Earth is 32 feet per square second. Now, this might be a formula you're kind of familiar with if you have taken physics. That probably they're going to do it in meters instead of feet, but we will typically be in feet. Now, so if you consider for a second that this is really just -1/2 times 32, this will always be a -16 for a coefficient. And in fact, sometimes they just give us -16. Sometimes they make us remember that the acceleration due to gravity is 32. Anyhow, so it's going to be a -16 t squared. T is time, that's your variable, plus your initial velocity, so how hard you hit it or how hard you threw the ball, initial velocity times time, and then, oh, and I should say anytime you have this little sub O right here, that is initial. So this is the initial velocity, this is that initial position or initial height of the ball. All right, so using this formula, and you have to know this ultimately is what you have to know. Let's look at an example. We have a pitching machine that's going to throw pop-ups to us. So it's set to throw with an initial velocity of 48 feet per second from a height of 3.5 feet is where it's pitching from. All right, so we're going to write the model, which just means plug in your numbers. So it's a function of position with respect to time, and the negative 1/2 g is going to be a negative 16 t squared plus, and then initial velocity, they said was 48 t, plus initial height is 3.5. All right, so there's the model. And then we can use this model. Now we should really, when we look at that, we should know that that's going to be a parabola. And because a is negative, it's an upside down parabola. And so their question to us is, what is the maximum height and the time that it takes to reach that height? So this, well, in all honesty, you could do this algebraically or you could do it graphically. Probably most students like to do this graphically. So you would just go to your calculator. And I've already done this. So your x-axis is time. Your y-axis is your height or your position in feet. And this is in seconds. Okay, so the ball started at 3.5 feet. So you should not be starting at the origin. It starts up here. And I just went to 100 here. I thought, that'll probably be enough. I went to 5 seconds because I feel like that's a long time for the ball to be hanging out in the air. And that was a good window right there that I did. It kind of just came up and back down. It looks like that. Okay. So really what you're looking for is this point right here, which is the vertex of the parabola. So since this one is in general form, you could go do the negative b over 2a and find the vertex, and that would find what you wanted. So you might choose to do that. The numbers aren't terrible. If you're doing it on your graphing calculator, then you have to find this ordered pair. And that ordered pair is a maximum. So you go to second trace, and you would find the maximum there. Now, I'm not going to wait for you to do all of that. I'm going to hope you know how to work your calculator and that you could do that. And what you get for an ordered pair right here is 1.5, comma, and then 39.5. Now, I actually had something longer than 1.5. Remember that sometimes it'll go 1.49999. We assume that's a 1.5. Okay, so now I always want a sentence here. You can't just give me that answer. I want to know what the heck does that mean? And so the question is, what is the maximum height? So I'd say the max height is, do you know what it is? Okay, the y value is the height. So that's 39.5 feet. And it occurs then at 1.5 seconds. All right, so I for sure want labels, and I want to know that you know what those two different numbers represent. All right, so I'm going to call that good on quadratics, kind of a quickie overview and doing some applications. Now I'm going to move on to inequalities. And we're talking about a little fancier inequalities than what you have maybe done in the past. So I'm talking about polynomials, so they're going to be quadratics, or this one you can see is going to be a cubic. And then we're going to also do rationals on this. So to solve inequalities, we have to do sort of treat it like an equation. So in this case, well, and we are always going to be using what we call a sign chart, because we're going to pay attention to the signs, whether they're plus or minus. That's what the sign chart does. All right, so I kind of gave us a to-do list. The first thing you're going to do is set your polynomial equal to 0. So obviously I need to move these things over and solve. Now this is a cubic. It sort of looks like it's probably going to be something that I could do factor by grouping to solve. So I have x cubed plus x squared. I'm going to subtract the 4x. I'm going to subtract the 4, greater than or equal to 0. Now, it did say set it equal to 0. Okay, so I have to remember this for later. It's a greater than or equal to, but I am going to kind of think of it as an equal sign for right now. And I'm going to do factor by grouping. Remember, with that minus sign, you got to do a plus a negative like that. I can factor in x squared out of the first one. I'm going to factor out a negative 4 on this one. and I conveniently end up getting the same quantity there. That's what I want to have happen. So then what I do is I pull that out and say, all right, it's x plus 1 and x squared minus 4. However, x squared minus 4 is a difference of squares, so I'm going to keep going. So I have x plus 2, x minus 2. Oops, okay. So I'm a little afraid I'm going to run out of room. So I'm going to write my solutions over here. X is equal to negative 1, negative, well, I'll just write plus or minus 2. We have 3 different solutions there. Those are what we call our boundary points. And what they indicate is something is happening on the graph at these points. So I'm ready for step 3 now. It says test a value in each section of the number line and see if it works. Okay, sorry, I should have read step 2 first. Use those solutions as boundary points on a number line. So here's what I've got. I've got this number line here. And I'm going to put those 3 values on there. So it's a negative 2, it's a negative 1, and a positive 2 over here. And now I'm ready for 3. It says test a value in each section and see if it works in the inequality. Testing in the factor version can be more efficient. So here's the deal. I'm going to pick a number that falls over here on this side of the number line. So probably negative 3. And I'm going to put negative 3 back into the original. And really, I could go here. I could put it in the original to see if it works. I could put it in here, really, to see if it works, to see if I put in a negative 3 here and here and here and evaluate all of that, does it end up being greater than or equal to 0? But it's even better just to put it in this stage right here. Because I don't really care what it equals. I only care if it's greater than 0. I'm looking for the sign of it. Is it going to be positive? Is it going to be negative? So think with me here. What if I put a negative 3? If I put a negative 3 into this quantity right here, I'd have a negative 3 plus 1, and that would be a negative 2. Really, all I care is that it's negative. So I put a little negative there. Then I put negative 3 right here. Negative 3 plus 2, that's also going to end up negative. Again, don't really care what the number is. I just know it's going to be negative. If I put a negative 3 in this third one, it's also going to be negative. And what that means is that I'm going to be taking a negative times another negative times another negative, which is going to end up being negative. All right, so now we're going to go through and we're going to do that in every section. So now I have to pick a number that falls between negative 2 and negative 1. Well, I'm going to go with a negative 1.5. It seems like that's going to be tricky, but it's not because I'm not really evaluating anything. I just have to decide if it's positive or negative. So if I put a negative 1.5 right here, that's going to end up negative. If I put a negative 1.5 in the second one, that's actually going to end up being positive because the 2 is positive or is bigger and it's positive. And on the last set, if I put in a negative 1.5, I'll end up with a negative. Okay, so I have a negative times a positive times a negative. All right, those 2 negatives are going to make that thing go positive. So this is going to end up positive in that range. All right, again, trying something in the next section. All right, 0 looks like that would be an easy value to plug in. So I plug in 0 here, that would be positive. 0 here would be positive, but 0 here would be negative. So I'm doing a positive times a negative. If I were to take a positive number times a negative number, it's going to end up negative. All right, last one. I'll give you a second. You go do it. Let's say you're putting in a 3. Go do it. Decide what you think it's going to be. All right, hopefully you said it was positive, 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 which means it's going to be positive. Now at this stage, what you do varies depending on the original problem. The original problem, which I've converted over to this, is a greater than. I am looking for x values that will end up make it being greater than 0, which means down here, I want the ones that are greater than 0. That means I'm going to want the positive sections. Those are the values that will work, that will end up making that be greater than or equal to 0. So then I write my answer in interval notation of those areas. So I'm going to go from -2 to -1. And since it is an or equal to, those would be brackets. In union with, I would also have from 2 to infinity. And those are my solutions. And so I could, I don't know if I want to write x equals or something. I just want you to recognize that's not a domain or something. That those are your solutions. That's the intervals that you could plug in numbers that would make this inequality work. All right, so that's kind of the whole shebang. And no matter what type of problem I give you, this works for any kind of inequality. It'd work for an absolute value, but we're going to focus mostly on polynomial functions and rational functions. Now, there are a lot of steps involved in this, so I would like you to really try to do one all by yourself. And so why don't you just pause the video and try to look back at the to-do list and see if you could do this one on your own. All right, so I'm going to wait. You pause the video. All right, so I hope you tried that on your own. This is what I ended up with. If you got this and it looks like you did the same thing I did, great. Let's keep going. If not, let's take a minute to pause the video and check out and see where you may have gone wrong. I think it's nice sometimes to have a visual that sort of goes along with that to see what's going on. That's why we look at graphs, to get that visual. And so if you look at, this is actually the parabola I just graphed. It's this one right here. And when you do that, you can see that here are the x-intercepts. Those are 2 and 5. Those were the two that I found. And the way that this thing is graphed, well, you can see that if you think of this as your 0 line right here, the chunk that we said is our solution is below 0. And the parts that we ended up with positive are these two legs over here. So graphically, this is what's going on with these. All right, I'm going to do one more example. This time it's going to be a rational inequality. And so the to-do list is very similar. You're going to set the rational equal to 0. Now this is where it's a little bit harder probably. You have to get a common denominator to merge it into one fraction. Once it is a single fraction, then you go to step 2. Values that make the numerator equal to 0 or make the denominator equal to 0 are your boundary points. Those are going to be something is happening on the graph at those two places. Now, if you'll remember from our polynomial bounce cut packet thing, anything in the numerator, there's going to be an x-intercept. Anything from the denominator is where there's going to be an, oh, looks like I misspelled that, asymptote. Okay. So those are the boundary points. We'll sit there and set up a number line and use those. And we're going to go through and check the whole positive, negative thing and do the same thing we just did. One thing to note, though, is be careful with the asymptote. X cannot equal that. So even if you had an or equal to kind of a problem and you feel like it should be a bracket, it can't be a bracket if that's where the asymptote is. And you would have to acknowledge that. All right, so I kind of picked out a problem I think is going to be good. It's going to touch on some of those things we just talked about. So what I'm going to do here is I'm going to subtract that 2 to begin with. And I'm going to write it over 1. I'm going to have to get a common denominator to merge that into one fraction. So that means I'm going to have to take, your common denominator would just be an x plus 3. So I'm going to take this top and bottom times an x plus 3. And be careful with this minus sign here. We've talked about this, that this minus sign is going to affect everything. So I like to do a plus a negative so that I'm going to end up distributing a -2, and it's going to go to everything that way. So now I'm going to have a common denominator of x plus 3. In my numerator, I'm going to have an x plus 1 minus a 2x minus 6. Again, I mean, it says that it's a less than or equal to 0. That's good. You can also just think of it as an equation for right now. you're just simplifying it. It's x plus 3. Looks like I have a negative x and a minus 5. All right, so now anything that makes my numerator equal to 0 or my denominator equal to 0 will be my boundary points. Sometimes you can just do that in your head. This numerator is a little bit wonky because it's got the negative in there. So remember that if it's not something that you can calculate in your head, just give yourself a little equation over here, a little side note, and say, I need that to, well, I need it to not equal, well, no, I'll just set it equal to 0. And then I'm going to add x to the other side, and I've got it. Okay, so x being negative 5 is what would make that be 0. All right, so here we go. I'm going to make my number line now. And my two boundary points are going to be that negative 5 right there, and the denominator, that would be a negative 3. Now you're going to do test points, and I think I'm going to go right here, and I'm going to go and do my test points here and pay attention to if it's going to end up in the numerator, if it's going to be positive or negative, and in the denominator, if it's positive or negative. So picking a number in this section here, that'd be a negative 6. If I put a negative 6 right here, it would change to a positive 6 minus 5. All right, that's going to be a positive number. But if I put a negative 6 in that denominator, it's going to end up negative. So I'm going to take a positive number and divide it by a negative number, and that's going to end up being negative. All right, let's try something in between them, probably like a negative 4, I guess. So if you put a negative 4 right here, that negative is going to change it back to a positive 4. 4 minus 5 is negative. If I put a negative 4 in the denominator, that's going to end up negative also. And a negative divided by a negative is going to end up a positive. Last one, let's put in, I'm going to put in 0. Let's just put in 0 because it's on that side over there. 0 right here, I would just end up with a minus 5. 0 here, I'd end up with a plus 5 or plus 3. So I'd have a negative over a positive, which is a negative. Now, to decide what section you want, you always have to go back to this inequality sign. This time we're looking for all the values that are less than 0. If I'm looking for the ones that are less than 0, then I am looking for the negatives. If it was a greater than, I'd be looking for the positives. I'm looking for the negatives. It is an or equal to, so that would tell me to use brackets, except that this right here is creating an asymptote. So even though it says or equal to, I cannot let it actually equal negative 3. So here's what your answer would look like. Negative infinity to negative 5. Put your bracket on your negative 5. In union with, pick it up again at negative 3, but it can't actually equal that because it's an asymptote to infinity. And there is our solution. Okay, I think they're kind of fun. Hope you do too. All right, good luck.